Hello class, this is Miss Taylor and we are going to try what is called a flipped classroom. So I will be doing videos from now on and you will watch them for homework, and then in class we will actually do the problems and do more labs, attempt that. So section 1 is Intro to Stoichiometry. So what is stoichiometry, you ask? Well, first let's go over the objectives. So objective 1 is to define stoichiometry, and I will tell you what that is in just a moment. Objective 2 is to describe the importance of mole ratio, and we learned about those in past reactions. When we look at the reaction, we know that so much reactant makes so much product, and we can look at the mole to mole ratio in that using the coefficients. They are important in stoichiometric calculations. And then we will refresh how to write a mole ratio relating two substances in a chemical equation. So we've done that prior, we will just refresh with that. So stoichiometry, there are two types. We're going to talk about composition stoichiometry, which deals with the mass relationship of elements and compounds, and we will talk about reaction stoichiometry, which I can bet you can guess involves the mass relationship between reactants and products in chemical reactions. So we can see that this is the elements in the compound, so if we're looking at a specific compound, and this talks about the reactants versus the products. And now I'm going to ask you, what's the difference between a reactant and a product? The reactant are the things that react to form the product. So on the left side of the equation, we have the reactants, and then on the right side, we have the products. So if we look at reaction stoich problems, we can look at ones that just give, they have given an unknown amounts in moles. So we are given the amount of moles in a substance, and we are looking for the amount of unknown moles in a substance. And here we would use the mole to mole ratio. So given our problem type 2 is when we have an amount in moles given, and then an unknown is the mass. So we're looking for the mass. So we start with the amount of given substance in moles. We convert that to the amount of unknown substance in moles. So we do the mole to mole ratio. And then from using what? The molar mass, we can figure out the grams of unknown substance from the moles of the unknown substance. So then there's a third type. If we have a given mass and the unknown is an amount in moles. So first we start with the grams of the unknown, and then what do? Convert it to moles by using what? The molar mass. You got it, guys. And then you do the what? The mole to mole ratio. So we finish with the unknown in moles. Then there's another one. Oh man, look at that. So we have a given amount in mass. We are taking this one step further, and then we want the unknown in mass, but we can't just jump from grams to grams. How do we get from grams to grams? We use the mole ratio. See how important that is, guys? So we have the we have the given in grams, then we can figure out the given in moles, then we can figure out the unknown in moles by using the mole to mole ratio, and from grams to moles we would use the molar mass. So then to figure out the grams of the unknown substance, we can go from moles to grams using what again? The molar mass. Yeah. So if we look at this, here's an example. So mole ratio is used as a conversion factor. So this is, we do not worry about the sig figs in these coefficients. Yes, there's only one, but our answer should not only have one. So a conversion factor we learned before relates the amounts in moles of any two substances involved in a chemical reaction. So we can say for every mole of aluminum oxide we have here, we have 2 moles in this equation. So for every 2 moles, we have 4 moles of aluminum, and we have 3 moles of oxygen. So if we have 4 moles of aluminum, for every 4 moles of aluminum, we always have 3 moles of oxygen. So we can see the mole ratios, which you guys have done before. Okay, so if we look at converting between amounts in moles, we talked about how we just use the mole-to-mole ratio. So we go from the mole of known to the moles of unknown. So if we are given, let's say, for instance, we are given 10 moles of aluminum oxide. So let's write, let me do it in a different color so it stands out to you. So 10 moles of aluminum oxide. How many moles do we have of oxygen? We use the mole-to-mole ratio. So if we have 10 moles of aluminum oxide, how many moles? What's the mole-to-mole ratio? For every 2 moles of aluminum oxide, we have 3 moles of oxygen. So let's do that math. 10 times 3 is 30. Divided by 2 is 15. And because we have 3 sig figs here, we have 3 in our answer. Well, what about aluminum? We would just simply, we could erase this and say 4 moles of aluminum. 10 times 4 is 40, divided by 2 is 20. So that gives us 20 moles of aluminum. So we see that's the mole-to-mole ratio. And that is how we figure out the moles. If we are given an amount in moles, we go to an amount in moles. So let's go one step further. Here. Let me write the equation so we can see it again. Moles of aluminum oxide. Looking at this, what type of reaction would you think it is? Just think about that. Think about that, guys. We have, let's say, XY, and it breaks down into X and Y. Decomposition. Good job, guys. Okay, so looking at this, what if we are given, let's stick with 10 moles. But we want the grams in oxygen. So we start with 10 moles of aluminum oxide, do dimensional analysis, plug in the mole-to-mole ratio, which is for every 2 moles of aluminum oxide, we get 3 moles of oxygen. Sorry, let me rewrite this, 2 moles. Make sure you write out your units so then you can cancel out. We know this is, moles of aluminum oxide, leaving us with moles of oxygen. But we don't just want moles this time, we want grams. So let me ask you, what is the molar mass of oxygen? If we glance at the periodic table, we know the molar mass is 16 grams per mole. But oxygen is diatomic. Therefore, it's 16 16 times 2, which gives us 32. So we say for every 1 mole of oxygen, we have 32 grams of oxygen. Moles of oxygen cancels out, then that gives us 10 times 3, which is 30 times 32. I need a calculator for that. 30 times 32, which gives us, I added 960, then divided by 2, which would give us 480 grams of oxygen. But let's take it one step further and say, okay, we have 480 grams of oxygen. Now, how many grams would that give us of aluminum? Let's look. So we know the ratio between oxygen and aluminum is 3 to 4. Remember that. So we are starting with 480 grams of oxygen. We have to go backwards again. So now we go 32.0 grams of oxygen for every 1 mole of oxygen. And then we said the mole-to-mole ratio is what? For every 3 moles of oxygen, there's 4 moles of aluminum. And now we need the grams of aluminum. So for every 1 mole of aluminum, we have, let me glance at the periodic table, 26.98. That then, if we multiply the top out, 480 times 4 times 26.98 divided by 32 times 3, then gives us 539.6 grams of aluminum. So we have now went from moles to moles, from grams to moles, and from grams to grams. So you should now be able to do this on your own, and that is section 1. And next time we will go into section 2. Have a great day.